Welcome to CSEGuru. In this session, we will discuss the topic evaluation of postfix expression. Consider the given infix expression. This is the given infix expression. We need to evaluate this expression. So, the given infix expression directly we cannot able to evaluate. So, the infix expression should be converted into postfix expression. Then the postfix expression only we can able to implement with computer code and we can able to evaluate the expression. So, conversion of infix to postfix expression is the first step. Suppose if they have given directly the postfix expression, directly we can implement and evaluate the expression. Since they have given infix expression here, first we need to convert it into postfix expression. The given expression is 10 plus 2 open parenthesis, 7 minus 5 close parenthesis plus 10 again close parenthesis divided by 2. For the conversion of infix to postfix expression, we need to know the precedence rule. So, precedence rule, if you are considering in the sense here, bracket is having the first preference. So, innermost bracket, the elements first we need to convert it. Okay, so here 7 minus 5, the first operand is 7, second operand is 5, operator is minus. So, postfix expression is operands will come first, operand 1 and operand 2 will come first, so then comes the operator. The remaining as it is you write down. Okay, so here we have converted this innermost bracket. So no need to add the bracket. Plus 10 divided by 2. Again bracket is there. So this bracket you need to give next preference. So here 10 plus. In this bracket first operand is 7, 5 minus. Second operand is 10. So first operand 7, 5 minus. Second operand is 10. Operator is plus. Divided by 2. The whole thing you need to consider as one single operand after its conversion. Next is, here addition operator is there, next division operator is there. So, among these two operators, division operator is having higher precedence. So, first we need to convert this division operator into postfix expression. So, 10 plus, first operand is this complete thing, 7, 5 minus 10 plus. Then, second operand is 2, division. Operator is division. Next, only addition operator. First operand here is 10. Second operand is this whole thing. So, 7, 5 minus 10 plus 2 division. And here the operator is plus. So, this is the postfix expression for the given infix expression. And this expression only we are going to evaluate with the help of stack data structure. Now, this infix expression, you have converted it into your postfix expression. What is the postfix expression you will get it? It is 10, 7, 5 minus 10 plus 2 division again plus. Okay. So, what is the algorithm to evaluate the postfix expression? First step is add a closed parenthesis at the end of the postfix expression. Now we have added a closed parenthesis. What is the purpose? Already we know. To represent the end of the postfix evaluation. That is, the evaluation comes to an end. To represent that, we are adding a closed parenthesis at the end of the postfix expression. Okay. Next step, if the character is an operand in the sense, push it onto the stack. If the character is an operator in the sense, pop the top two elements from the stack and implement the corresponding operation, and again the result you have to push back into the stack. This procedure continues until you evaluate all the input characters. Okay, once you reach this closed parenthesis, the expression evaluation comes to an end, meaning all the characters in the postfix expression we have evaluated. That is the meaning. Okay, so this procedure will continue until you reach this closed parenthesis. So, first initially nothing will be in stack. Now, first element here is 10. So, push, it is an operand. So, push operand into stack. And next, the remaining input characters are 7, 5 minus 10 plus 2 division plus. And 10 you have to push it onto the stack. Okay. And the next character is an operand. If it is an operand, push it onto the stack. Push 7 into stack. Now 10 will be at the bottom. At the top element 7 will be there. Okay. The remaining input characters are 5 minus 10 plus 2 division plus closed parenthesis. Okay. And the next step, the next character is an operand. So if it is an operand, push the operand 5 into the stack. Now the topmost element will be 5. Whatever the element you are placing, that will occupy the top position of the stack. So now the recent operand we have pushed into the stack is 5. 5 will occupy the topmost element. And the remaining input characters are minus 10 plus 2, division plus closed parenthesis. Okay. Next is the operator. So whenever you are reading an operator, pop the top 2 elements from the stack. What is the top 2 element? 5 and 7. Okay, if you are removing 5, the next top element is 7. So 5 and 7 you have to remove from the stack, that you have to pop from the stack, implement this subtraction operation, and the result you have to push back into the stack. Okay, so here pop 5 and 7. The first element 5 will be considered as A, second element will be considered as B. And we have to implement the operation B operator B, the corresponding operator with A. Okay. So B is 7, corresponding operator is minus, A is 5. And what is the result you will get? It 2. Now the result 2 you have to push back into the stack. Okay. So now the top 2 elements we have popped and we have implemented subtraction operation, and the result you have to push back into the stack. Okay. The remaining input elements are 10 plus 2 divided by plus and closed parenthesis. Okay. And the next comes the operand. Push the operand 10 into the stack. If it is an operand, you have to push it into the stack. So 10 is at the bottom, 2 is next top element, current top element. If you are pushing this element 10 into the stack, this 10 will occupy the topmost position of the stack. And the remaining input characters are plus 2, division plus closed parenthesis. And the next comes the operator. So if it is an operator, pop the top 2 elements and implement the corresponding operation. So pop 10 and 2. What is the operation you have to implement? Addition. So element B is 2 plus 10. The result you will get it as 12. Push the result 12 into the stack. Okay. So now the top 2 elements we have popped and we have implemented addition operation. So 10 and 12, the result 12 you have to push back into the stack. And the remaining input characters are 2, division, plus and closed parenthesis. And then the next input character is 2. 2 is an operand. So push the operand 2 into stack. So now the topmost element is nothing but 2. Okay. And the remaining input characters are division plus closed parenthesis. Next comes the operator division. So pop the top 2 elements. Pop 2 and 12. Then implement B by A. Okay. So 12 divided by 2, and the result you will get it as 6. Now push the result 6 into the stack again. So 10 and 12 divided by 2 is 6 you will get it. The remaining input characters are plus and closed parenthesis. Next comes the operator. If it is an operator, pop the top 2 elements. Top 2 elements now here is top element is 6. Next top element is 10. Okay. So top 2 element is 10 and 6. So here pop 6 and 10 and implement 10 plus 6. So you will get it as 16. Now push 16 into the stack. As a result, 16 you have to push back into the stack. Now only closed parenthesis. So whenever you are reading the closed parenthesis, it means the input character comes to an end. That is, the postfix evaluation comes to an end. That is the meaning. Now we have to stop the algorithm. So here stop or exit. So what is the result you will get it? The value 16 you will get it. So here the postfix expression 10 plus 7 minus 5 plus 10 divided by 2. If you are implementing, that is, if you are evaluating this expression, the result you will get it as 16. So this is the output of this evaluation of postfix expression for this given infix expression. Thank you for watching this video.